Okay, what we're going to do here is very briefly discuss what happens when we actually try to find the flux of a vector field where the arrows keep changing through S, which is not a flat little thing. What we do is we zoom in on the graph anywhere we want to, so much that we actually can see a flat little patch. Now that flat little patch is going to have area, usually they'll call it delta area like this. Now what do we need? We know that the vectors, if I pick the patch small enough, yes, all the arrows all look pretty much the same there, so I can just take that and plug in one little point, and then what do I have to do? The same thing we did when we had flux of a constant velocity through a patch. We need a vector that's sticking directly out of the patch. We need to find the projection of our velocity onto that vector so that we get the actual velocity passing through the patch, and then we multiply by the area of the patch, and that will estimate the flux of our velocity field going through the one little patch. We then do what we always do with calculus. Yes, we say that's the velocity through one little patch, and I want one little patch. I want to add up all the fluxes for all the little patches, and then I want to add up all those, and that'll actually give me a estimate of the flux through the whole bowl. And then I want to make it perfect, so we're going to take a limit. Delta x has to be small, delta y has to be small. We'll get detailed reasons of why, 4 at least reasons why we need all that. But when we're done, we're going to get a double integral. We're going to get a double integral. The only variables are going to be the variables down here. So what we're actually going to get in very general notation is going to be f. Remember, we call this the area vector, so what we'll usually write is a little area vector here like this, and they'll say s, because the surface is actually where we're putting all of our little rectangles. When we set this up, we're going to get an integral with x and y values down here, so it's nothing to worry about, but we are going to get an integral we can do, an integral like we've been doing all semester.